To wrap up this section, we want to stop spawning apples and then also destroy the remaining apples if apples lost is greater than 3. I will begin by destroying the remaining apples, since that is a bit simpler. To achieve this, all we want to do is we want to find all of the apples that are currently in the level, so all the apples that are left in the level, and we want to call destroy on those. We have a handy helper function for this in gameplay statics called getAllActors of class. For the world context object, I will actually pass in something else other than this, such as getWorld, which will return a pointer to the world. We know that the world should exist when we call this function. Next, since we don't set up a pointer to an actor property for this class, to pass in here, we can use the static class function. Since we want to get all actors of the apple base class, we will do apple base, but we don't have the header included for that yet, so I will include that. Now we can do a apple base, : and the static class function. The static class function returns an uClass object representing the particular class at runtime. For the next parameter, notice that this is a reference to a t-array of pointers to a actors. Also remember the out parameter prefix indicates that the function may modify what we pass in. We don't have a t-array to pass in yet, so let's define one now. A t-array of pointers to a actors, and I will name that foundApples. Pass that in as the third argument. So the getAllActors of class will modify that array to store pointers to all actors of that type. Now we can iterate through that array using a for loop. For each pointer in that foundApples array, we want to cast and make sure that we have an apple base, not just any actor, and we can assign that to a temporary pointer. Now if that temp pointer is not null, then destroy that actor using the destroy function. All of the actors in the foundApples t-array should actually be of type aAppleBase, so we could just call pointer destroy, for example, but I want to demonstrate how we can do a check like this, because that will come in handy in the next section, where we want to stop spawning apples. Alright, next on our to-do list is we want to stop spawning apples. So we can do something similar that we did here for the destroy remaining apple section. So what we want to do is we want to find all of the trees. For that I want to include the tree base header because I will be calling a function on that. I will make sure that we return a uClass object of the correct type, in this case a tree base. And then we want to store the results or the pointers in the found trees t-array in this example. We can do something similar with the for loop. In this case, we want to iterate through the found trees t-array, and we don't want to call a function on just anything here. We want to cast to a tree base, because we will call a function which we will actually implement here in a second in the a tree base class, and when we call that, that should stop spawning apples. Alright, so let's go to the tree base header and we will declare that function void stop spawning apples. Next we want a boolean which will allow us to set whether or not we want the tree to execute its movement logic. I will name that bool should move. In the constructor in the source file, I will move the commas around a bit. They should be at the beginning of the line here. And I'll initialize that to true for now. Actually, I'll prefix the shouldMove variable with b, a lowercase b. Now that is easier to recognize as a boolean. I will use quick actions and refactorings and create the definition of that function in the source file. I will actually move that down. I prefer to have the constructor begin play and tick close to the top of the file, since we typically look for those first before we look for any other functions. Remember how we set timers. So in the begin play for this class, we do getWorld, getTimerManager, and then we set a timer. Well, in the stop spawning apples, we can do getWorld, getTimerManager again. But from here we can now call the clear timer or clear all timers. But let me just demonstrate clear timer first. This has a reference to an ftimer handle. Remember we have the apple spawn timer and the change direction timer. Those are ftimer handles, so we can pass those in. But in this case I'm actually going to do both of those, so I'm going to clear all of the timers. We can do that with getWorld, and then you may have seen this one previously, clear all timers for object, and I will pass in this. Now I also want to set should move to false. When we stop spawning apples, we want to set movement to false. So for an exercise, I want you to try and do that by yourself, because here we are simply changing the boolean to false, and that is not really going to do anything at the moment. So for an exercise, I want you to think about how we can actually stop the movement by using this boolean variable. Go and implement and test the logic. Alright, I'll just continue here. Of course, our movement logic here is defined in the tick function. So what I can do is I can select that logic, and then I can surround that with an if statement. Then I'll simply pass that should move boolean in here. So if we should move, then get the location and execute the movement logic as we have set it up here. Add the offset and then set the new location. Remember, it's in the begin play function where we set those timers. So now in the stop spawning apples, we will unset those timers. Of course, you could have named this something else, or you could have split the functions up into smaller functions. So stop moving, stop spawning apples, stuff like that. But I may come back to that in the section wrap-up video. For now, we just want to test this. Now that we have this public stop spawning apples function, we can invoke that in the game mode. From that pointer, stop spawning apples. What's useful with this setup is we can have multiple trees in our levels if we want, maybe for some hardcore mode or something like that. It's always a good thing if your code is forward-looking in that way, even if that is not what you had intended. Build and run that. I will filter for apples in the outliner so that we can make sure all of the apples actually get destroyed. If we play test, once we lose 3 apples, we should stop spawning apples and the tree should also stop moving. We also notice that when we lose that final apple, the third apple, that leftover apple gets destroyed, and that is the behavior that we get. In the outliner, we can notice that all of the apples are gone, so they are all destroyed. They are either lost or collected, in which case they affect scoring somehow, and of course when we destroy the leftover apples, those are not supposed to affect the scoring.